This is Mr. Beck Does Your Homework. This is AP Physics, Homework 5.2, questions 8 and 9. A 0.379 kilogram mass is attached to a spring and executes simple harmonic motion with a period of 0.73 seconds. The total energy of the system is 1.6 joules. Find the force constant of the spring. So we have a mass that is attached to a spring and moving back and forth. So here's my spring, here's my mass, and it'll stretch out this way, and then it'll swing back to this way. So it's stretching the spring back and forth. The period is 0.73 seconds. So I know that my T is 0.73 seconds. And the mass is 0.379 kilograms. Find the total energy in the system is 1.6 joules. So somewhere I've got my energy, so I'll just write TME equals 1.6 joules. Find the force constant of the spring. Now, do I have any way of finding the force constant? This seems like a strange question. But I do, because I remember that the period of the spring is going to be 2 pi times the square root of the mass over the spring constant. And I'm looking for the spring constant. I know the period, I know the mass, so I can easily solve for the spring constant here. So this is going to be the period divided by 2 pi equals the square root of m over k. So if I square both sides, I get t squared over 4 pi squared equals m over k. So k multiplied by k, divide by t squared, multiply by 4 pi squared, and that's going to give me my spring constant. Now, part 9, question 9 says find the amplitude of the motion. Well, what's happening here is that I've got here, when it's compressed all this way, it's just going to be potential energy in the spring. Here in the middle, where the spring is at its equilibrium position, I'm just going to have some KE. And then here at this end, I'm going to again have some potential energy due to the spring. Well, if I want the amplitude of the motion, that is how far this is, or how far this is. So my amplitude is how far above or below, or how far to the right or the left of equilibrium. Well, now I can think of the energy stored in the spring. It's going to be 1/2 kx squared. Well, x is going to be the amplitude of the motion. So x equals the amplitude. It's how far from amplitude. How far from equilibrium. I compress it. And when I compress it, the block comes to rest, so I have no KE. So that's just going to be my PE of my spring. So I've got my PE of the spring is going to equal 1/2 kx squared. Well, I know my PE of the spring is my total energy, because at this point it's all spring. So I've got 1.6 joules equals 1/2 of my spring constant, which I got from over there, times x squared. And you can solve this for x to get your distance that is the amplitude of the motion.